And here I'm doing part 2 of the review guide for the test next week. Current I is the charge per time. So it's the charge per time. The rate at which charge moves, so I guess, like I equals Q over T. And the unit of current would be a coulomb per second, or that would equal an amp. The resistance is equal to rho L over A, or it is the impedance to the flow of charge. And the units for resistance would be in this omega symbol, or that is in ohm. Voltage is the potential causing charges to flow. When you have a potential difference across two ends of a wire, you can get charges to flow, and we can use the equation V equals IR, and the units would be in volts. Power is again the rate of using energy, or the rate of doing work. And the equation for power, we can use P equals I times V. And the units for power would be in watts, or sometimes we will convert this to kilowatts for a household problem where we're talking about electrical energy. And let's see, energy is the amount of work a charge can do. The amount of energy stored up in that charge will tell you how much work it could change into and light your light bulb or heat your toaster. And energy would be the power times time. And the units of energy will often be joules. Or when we're talking a cost problem, like we're buying from ComEd, we do kilowatt hours for energy. So number 11, a silver wire is connected to a 9-volt battery. If a charge of 0.3 coulombs passes a point in 2 seconds, what's the current? I would be the charge per time. So 0.3 coulombs divided by 2 seconds. And you get 0.15 amps. The resistance, I have a voltage, so I can use V equals IR, where 9 volts equals 0.15 amps times resistance. And from there I do 9 divided by 0.15, and I get 60 ohms. If the resistivity, and the resistivity is ohm meters, that is telling you how much that particular type of wire impedes the flow of charges. And so if the resistivity is that and the radius is 0.32 millimeters, what's the length of the wire? So I'm going to use the equation R equals rho L over A. So 60 ohms equals 2.44 times 10 to the minus 8 ohm meters times L divided by A, and A is pi r squared because it's the cross-sectional area of a circle. So pi times 0.32, and milli just means 10 to the minus third, and that part's squared. So from there you can solve for the length. So 60 times pi times 0.32 to the minus 3 squared divided by 2.44 e to the minus 8 and I get 791 meters. If your light bulb is plugged into a 120 volt outlet and it has 0.5 amps of current, what's the power? We can use P equals IV. So 0.5 amps times 120 volts would be 60, and the units of power are watts. Now, if the light bulb is left on for 6 hours, how much energy does it use? Notice here, we're looking in units of kilowatt hours. So energy is power times time, but I have to convert from watts to kilowatts. So to convert from watts to kilowatts, I just go back 3 places. So it'd be 0.06 kilowatts times 6 hours, and I get 0.36 kilowatt hours. If the light bulb is then left on for 6 hours for 30 days, how much would it cost you? So we take 0.6 kilowatt hours per day times 30 days times 9 cents per kilowatt hour, and we would be left with just money. And so 0.36 times 30 times 0.09, you wind up with 97 cents. Okay. And that's all. Thank you very much. Happy studying.